Welcome everyone. I am Rashmi V. I created this channel to help students understand digital signal processing in a simplest way. Today we shall discuss the introduction to time domain signal, Fourier series, Fourier transforms and discrete Fourier transforms. What are time domain signals? A signal whose value is expressed as a function of time is time domain signal. There are two types: continuous time represented as x of t and discrete time represented as x of n. It shows how signal changes over time. For example, an audio waveform of the voice which we speak on microphone is voltage signal versus time. Example 2, the ECG signal where the heartbeats shown as a voltage versus time. Why time domain is important? Because in the real world, all the signals exist in time, but analyzing them in the time domain is difficult when they have a multiple frequencies. So it is very much essential for the practical need to convert the time domain into frequency domain representation of signals. So there are different types of converting the time domain to frequency domain. Some are frequency domain signals, some are Fourier transforms, discrete Fourier transforms and fast Fourier transforms. Before Fourier transforms, let's discuss about Fourier series. So what is Fourier series? So Fourier series transformation is nothing but for the signals of periodic signals. The Fourier series breaks any periodic signal into the sum of sinusoids. For example, imagine a musical chord made up of multiple notes. A sound formed by a musical chord is made up of frequency, fundamental frequency, and harmonics. Fourier series does the same to the signals. It finds the different notes in the periodic signals. But the limitation to the Fourier series is it represents only the periodic signals. So let's come to the Fourier transforms. Fourier transforms are for non-periodic signal. Practically in the real world, every signal will not be periodic. All the signals will be aperiodic. The Fourier transforms shows what frequency exists inside any signal which are aperiodic. Fourier transforms works for the signal that do not repeat itself, such as human speech, ECG or any real world signal. Fourier transforms is like a prism of sound. Just like a glass prism splits the white light into colors, Fourier transforms does the same for the signal. It splits the signal into different frequency components. Fourier transforms majorly used in the audio processing, image processing, radar and biomedical signals, etc. So Fourier transforms works on the continuous time signals. But practically, when you have to process a signal in a computer or in an algorithm, you cannot use the algorithms on the continuous time signals, because continuous time signals consider them as a signals infinitely continuous. That means the Fourier transforms assumes the signals exists from negative infinity to positive infinity. So practically it is not feasible, or practically it is not flexible to fit into a algorithm. So we introduce discrete Fourier transforms. So discrete Fourier transform converts the time domain sampling into frequency domain sampling in a discrete samples. It turns the frequency analysis into a simple sums and multiplication that the computer can calculate much faster than any other method. So using discrete Fourier transforms and fast Fourier transforms are the super fast algorithm for any signal to be processed, such as audio, equalizer, ECG, radar, mobile signal, image processing, any of it. This is the time domain representation where we convert into a frequency domain using Fourier series, Fourier transforms and for discrete Fourier transforms and discrete time Fourier transforms. So the music example of a music we can consider here. A song has a vocals, drums, guitar, bass mixed together inside a song. So discrete Fourier transform separates into frequency components used in the spectrum analysis, equalizers and audio tools. For example, if you take a music system, you can adjust the music's bass, and you can equalize the voices, and also you can adjust the pitch and node of the music. So all these are possible only because of discrete Fourier transforms that will be used in the that will be used as algorithms and as softwares integrated into your music systems or into your mobiles. So so fast Fourier trans so Fourier transforms and Fourier series, these both are mathematically very tedious, but these process leads to the discrete Fourier transforms. So today we have discussed a very minute introduction for the discrete Fourier transforms. In next videos, we shall dive into the syllabus of discrete Fourier transforms as per the VTU syllabus, and we shall get ready for the coming examinations. Thank you.